Okay, welcome everyone. I'm Louis Jacomet, your host for today's Gradle release presentation. We will go over the 8.2 release and its different features with a number of engineering speakers from the team. So first of all, we released 8.2 on June 30th. After three release candidates, we have a release that has quite a number of changes with nearly 1,500 commits, 76 fixed issues, and as you can see, quite a number of code changes, whether it's additions or deletions. And thanks to our community, we actually have 9 external contributors, so thanks a lot to all of them. I will not try to read their names because I may just fail on some of the peculiarities of them, but yeah, it's really appreciated to have contributions from the community. 8.2 is already outdated in a way because we did release 8.2.1 on July 10th. It fixes 5 reported regressions, but also it clarified that we have an ID sync memory improvement that we'll discuss later that was actually already part of Gradle 8.2. And so we definitely recommend for users to upgrade to 8.1 instead of 8.2. So with this, let's go over the different features. So we'll start with the Kotlin DSL that sees a number of improvements. We'll discuss that ID sync memory improvements. Then we have a slew of other improvements, including improved console output. So for the Kotlin DSL improvement, first off, we've got Anja about the simpler property assignment. Go ahead, Anja.
So simpler property assignment is enabled by default in 8.2. So if you're not familiar what that is, you can see the example below. Basically, if you have like a property on your extension or a task of type property, then before that feature, you had to use like this .set method, so description .set some value, right? But now you can just use like regular assignment that comes more naturally to a lot of users. Now this feature is still incubating and can be opt out, but we believe it will be stable really soon, probably already in 8.4. We also wrote a blog post about it. So if you want to get more information about it, check that blog post.
Okay, thanks, Anja. And so we jump on to Jozef for more Kotlin DSL goodness.
Okay, so before 8.2, the Kotlin DSL reference docs weren't maintained. There was just some old obsolete version linked from the manual. From 8.2, we have a new one which is up to date, and it's properly maintained from now on. It's published alongside the manual, and it's linked from there, but it's basically at the link provided in the slides. It's based on Docker, actually Docker 2, which is a Gradle plugin, but still based on Docker. So it generates content familiar to Kotlin developers, and contains both Kotlin and Java APIs. So Java members and Kotlin extensions intertwined in an understandable way, and has a search engine included in the page. Another thing we introduced in 8.2 for the Kotlin DSL is that Gradle Init now defaults to Kotlin DSL. So whenever you generate a new project, Kotlin DSL is the default choice, and also in interactive mode, it's the first option. And the last thing I'm going to speak about is a flag we introduced for the Kotlin DSL. It's called all warnings as errors. And its purpose is to make the build fail if any of the Kotlin build scripts generates warnings. And there's at the top of the slides, there's an example. And then in the middle, you have a list of the kind of warnings you can turn into errors, build errors like this.
Thanks, Jozef. So let's jump into the ID sync memory improvements. Sergey, up to you.
So the tooling API is a part of Gradle that used by the external tools like IDs for communicate with the Gradle. And this communication is done in in between the two components, the client side of tooling API and the daemon side of tooling API. The client side of tooling API is embedded to the external tool, for example, to ID, and daemon side is embedded to Gradle versions that run in the build. So 8.2 brings optimized structure for models caching in the tooling API, and end users can get benefits only with upgrading a daemon version of Gradle from 8.1.1 to 8.2, and can partially get benefits. But maximum of benefits will be available as soon as IDEs upgrade the client to the API client to 8.2 version. So at this graph, you can observe the results of memory consumption for a relatively large Android build. So here you can see observe an improvement that 8.2 brings. However, peak memory consumption reduces even more dramatically. Here you can see in results that gathered for pure Java project, but outside of real IDE. This is done with a synthetic tooling API client, and this is measuring peak memory consumption of tooling API overhead in isolation. So here you can see that reduction is dramatic. So you can expect more memory improvements in 8.3 as well.
Thank you, Sergey, and that's great. So now we're gonna jump into improvements without like left and right in the Gradle APIs and features. And we have a number of videos from the engineers that worked on these features.
This item is about the Gradle wrapper and specifically about an earlier validation of the distribution URL that you can pass to the wrapper. The Gradle wrapper is the preferred way of executing a build. It's a script that invokes a declared version of Gradle and downloads it if necessary beforehand. And that is used instead of relying on the local version that you can't really control. Most users are happy with the out-of-the-box configuration of the wrapper, but there are some scenarios where you might want to customize it. Common options to do so are --Gradle distribution URL and --Gradle version. With the first one, you can point to a Gradle distribution zip file, either passing it some HTTPS URL, or you can point to a file on the file system. With Gradle version, you set the Gradle version for downloading and executing the wrapper. And these values, when you set them, are written to the Gradle wrapper properties file. And then the next time you execute the wrapper, that's when those values are used for downloading the distribution zip. What already happens is that this is already failing. So if you have an invalid distribution URL, this fails, but only at execution time. We want to prepone this failure so that users get an earlier heads up, and we can prevent I/O exceptions at runtime. We do this by simply sending a head request or checking if the file exists at configuration time. And yeah, let me show you what this looks like. So here we have a little empty project. I'm just going to show you the Gradle version. So we're using 8.1.1. It doesn't have our change, and you can see in the properties file that this is also the version that the wrapper uses as in the distribution URL. So that's the default version the project was created with. So now if we pass it some Gradle version, as we do here, note that the version string contains capital letters. These are C. That's invalid. They have to be lowercase. So this should really fail. However, it doesn't. What happens now is only the second time we call the wrapper, it tries to download it with this invalid version string and fails. This is really bad, and we want to, as I said, prepone the exception. So yeah, what we do now is let's go back to the properties file, and we're going to change the version now. to 8.2 RC2. So that's the version that has our change. So the wrapper is now using this version. Now let's do the same thing again. We pass it this invalid version string. And yes, you can see it's failing right away, not only when it's trying to download it. It gives you the URL that was created, and you can also see the options and some pointers where you can find help. There are some scenarios where you might not want any networking happening. In this case, you can prevent this earlier validation with the --no validate URL flag. And as you can see, nothing is happening. Only later than when the wrapper tries to download the distribution, it will fail, as we've seen before. Alternatively, you could also use the --offline option to prevent any networking. Yeah, so this is the new feature. I hope you like it. This item is about Boolean task options and how we now auto-generate opposite options for them. So the Gradle documentation states for options that enable behavior, there should be the opposite option that disables this behavior. That is the case for build options, for example, --daemon, then you have --no daemon, or --parallel, the same thing. Unfortunately, this is not the case for Boolean task options. So for example, on the init build task, you have this incubating option, and that sets the value to true. So it allows you to use incubating APIs. But it's not possible to set this value to false. You can't pass a value, so say incubating equals true or false. So we wanted to solve this. And the way we do this now is that we auto-generate an opposite option for each Boolean task option. So yeah, let me show you some code. So here we have the already existing implementation of the incubating option on the init build task. And what happens here is you use this add option annotation, and that means that when you pass the incubating option to the task, this value is set to true. We didn't really want you to write any more code to add the disable option, so the auto generation happens in the background whenever a new option is added. What we do now is to check the name of the option. If it starts with the string no dash, then it's a disable option and the value will be set to false. Most of the time, though, it will probably start with something different and it's an enable option. So let's take the example of an option foo. We now auto-generate no foo, but for an option no bar, we also generate bar. The auto-generation only happens if there is no existing option with the same name. And let's say you pass both the enable and the disable option. In that case, the last one would win. Yeah, so let me show you what this looks like now on in a little sample project. So I'm using version 8.1.1, so pre-change. So now I want to, let's say, initialize a Gradle project, and I want to do that without any interaction. Let's say I do it programmatically from somewhere. So I'm trying to use this --no incubating option as the documentation tells me. And unfortunately, I get an error, the unknown command line option. So let's see, maybe I have to pass it a value. That works in most cases. No, it doesn't work here neither. Okay, so this was the problem we tried to solve. So let me move to our new version, 8.2 RC2. Now, if I run the same thing again with no incubating, it works. Nice. That's it.
Thank you, Lydia. So, and now some improvements on the toolchain side of things. Go ahead, Vlad.
Yeah, so extracting metadata from installed Java toolchains might take a bit of time during the first launch of Gradle if there were dozens of toolchains installed. It was a bit confusing to understand what's currently going on the previous versions of Gradle. In 8.2 we added a progress display for it. Most users wouldn't notice it, but it might be useful for framework and library offers which desire to test against many Java versions. And our feature we have is about improvements in the dependency verification area. So previously we exported PGP keys as is with all the metadata attached to it, like signs, maybe even photos of some people and stuff like that. In this release, we strip all the necessary information from the keys. So we leave in only user ID and the key itself. And also we duplicate them and store them in a predictable order, which should reduce the storage space and ease version control, updating the keys and stuff. And not that you might need to regenerate your keyring to benefit from this feature. That's it for me.
Okay, thank you, Vlad. And now we've got topics on build inits from Tom.
The Gradle Init utility has been enhanced with additional functionality in Gradle 8.2. You can use this utility to import a Maven build and convert it into a Gradle build. Previously, when importing a multi-module Maven build, that build was required to contain back references from child POMs to the parent POM. These back references are optional, and Gradle will now successfully account for missing back references and convert the project successfully. This allows us to convert more Maven builds on the first try without any additional tweaking, helping customers who are migrating from Maven to Gradle. The Configurations API in Gradle is undergoing a series of changes that will eventually make it more idiomatic and performant to use, as well as give it a lighter memory footprint. As part of this work, we want to notify build authors and plugin authors who are using the existing API in ways that are redundant or idiomatically incorrect. We've added many new deprecation warnings that will appear when this API is misused. Most of these situations will either become errors in Gradle 9.0 or be rendered impossible with the planned new API. These new warnings will give authors time to identify these misuses and update their builds. Gradle will now warn when copying a non-resolvable configuration, as the copy functionality is not a general case tool, but only useful for certain specific scenarios. Gradle will now warn when redundantly enabling usages on a configuration, such as calling set can be consumed on an already consumable configuration. We want to migrate to an API where usages are locked in place upon configuration creation, and redundant set calls are a code smell identifying places where the allowed usage may be too broad. Gradle will now warn when creating configurations with names that would be similar to the automatic names assigned to detached configurations, as this can cause confusion in reports. Finally, and most importantly, we have been able to identify some methods on the configuration API that should only be called when the configuration allows certain usages. Some methods should only be called on resolvable configurations, some on consumable configurations, and some on configurations that allow declaring dependencies. Gradle will now warn whenever these methods are called on configurations which do not allow the needed usage. For instance, the should resolve consistently with method should only be called on a resolvable configuration, as it will have no effect outside of resolution. If this method is called in a configuration which is only meant to be consumable by mistake or as part of the configurations.all block, the warnings will alert the author that this should be changed.
And now we've got Reinhold with the error improvements.
I'll show you what we did to clean up the output. Up until Gradle 8.1, there was some information in the output of compile errors that didn't help a lot to solve the problem. There was, for example, the hint to get help at help.gradle.org, which didn't make a lot of sense for compilation errors. Also, the use of --stack trace and --debug wouldn't get you any further in solving the problem. Starting now, we removed the not so helpful parts of the message, as you can see here. There is no more hint to look at help.gradle.org or to use the --stack trace and debug options to solve your problem. I'll show you a bit what we mean by reorganizing the console output. In this example, we try to use a dependency that doesn't exist. A suggested solution for the problem is in the middle of the message. We think that having possible solutions in one place is a better way to presenting this to the user. So now we're listing all the suggestions in the try section of the output, thereby clearly indicating that this might be a solution to your problem, and avoiding missing the actual suggestion when it's buried in the error output. Thanks, that's all I had to show on this topic.
Yep. As a conclusion to the 8.2 release, we also announced two security advisories about Gradle that are both related to past Traversal family of issues. One on the dependency cache, which users that have been using Gradle older versions would mitigate if they were using dependency verification. And then another one in the handling of tar archives. Both of them have a moderate severity of 6.9. And the path traversal one, like the tar archive one, also impacted the build cache. The good news, I guess, if there can be a good news with a security advisory, is that a remote-only exploit without build changes was only possible through man-in-the-middle attack or remote server takeover, like either your dependency repository or the build cache node or the server that was serving the tar archives that your build was using. Anyway, we still recommend that you watch out for any abuse of these and upgrade to Gradle 8.2.1 or 7.6.2 if you're still on the 7x line, because these advisories were fixed there as well. And that's it.